Good afternoon, everyone. My name is Kemal Sanjta, and I work as a customer success engineer at ThousandEyes, where we strive to provide network intelligence solutions to our customers. It's awesome to have the opportunity to speak in front of my home audience. I'm from Bosnia and Herzegovina originally. So this is something that I'm quite passionate about, network monitoring, and that's what I'm going to speak. Or more specifically, I'm going to speak about requirement to rethink, or do we need to rethink it, right? So regardless of the network engineering troubleshooting scenario, we always start with the issue, and the issue happens all the time. Uh, then we engage in troubleshooting, and we arrive towards the conclusion. And depending on the scenario and depending on the problem, we need to provide RCAs, which are root cause analysis. So that's pretty much a scenario for every single troubleshooting problem. So when it comes to troubleshooting, we end up always using two basic or traditional troubleshooting tools, and those are traceroute and ping. And for most part, they do their job, right? However, they have some historical inaccuracies, which comes in, when it comes to traceroute. Those are failure to discover nodes, or fail to discover links, or reporting of false. Looking a little bit deeper into this, we know that that happens because of the five-part tuple, which is used for a load balancing of the flows, and we know that the flows are what's mostly being load balanced on the routers today, or network appliances today. And when I say five-part tuple, what do I mean by that? Five-part tuple consists from the source IP and source port, destination IP and destination port, and protocol being used. And traditional traceroute suffers from the problem as part of which we send three probes with a limited TTL value as part of which we alternate source port, right? And this gives us the problem with the failure to discover nodes or links or reports the false links. When it comes to ping, for the most part, it does what it's supposed to do, and it does it well. However, there is a strong reliance on the control plane, so that's the problem there. And we take those tools as a good starting point, right? Those tools does the job, but we realize that we need something more. And those tools that we identified as a potential improvements are MTR, which stands for Matreshka Prober, which is this amazing tool that has the capability to recognize packet loss between source and destination on every single hop on the path between those two destinations. Paris traceroute, which fixes all of those problems with the five-part tuple, as part of which, for three probes that are by default sent toward the every single hop, the source port is fixed. And what that gives us is essentially stability when it comes to discovery of the load balanced path. So basically, from start to end, we basically have the pattern that's always the same. Doubling traceroute is this fantastic tool that has capability to peek beyond the NOT boundary, so basically we can find out the information behind the net. And our friends from the Netherlands, more specifically NL Ring, created this ring tool called NL Ring, as part of which there are certain participation requirements, but which are relatively easily to meet, as part of which you get quite powerful tool set from multiple different ASNs. So basically you have a possibility to SSH to a different network, as part of which you get different vantage points from which you can test your own target that you are interested in testing, which is quite fantastic. I failed to mention here RIPE Atlas project. Earlier on today, we figured out that Atlas has more than 10,000 probes deployed globally, which is quite remarkable effort from RIPE when it comes to providing additional vantage points. So we identified some of the improvements, right? When it comes to alerting, right? At the moment, we rely heavily on syslog, as part of which networking devices or networking appliances, depending on what you are using, are sending your logs towards the certain location, such as Splunk or something like that, and they are processed over there, categorized depending on the severity. SNMP is quite popular. Lately, streaming telemetry pushed by Google, for example, Google gRPC, and automation efforts, right, are quite popular as a alerting source, as part of which we started creating software solutions which are relying on SSH, and then basically we SSH the device, and using XML or something like that, we extract quite large amount of data which are not exposed, for example, by SNMP. So the real question here is, can your control plane handle it? And I'm going to give you two practical examples on this one. First example that I have here is that I saw the production environment that had the collectors implemented by SSH, as part of which a company was extracting quite large amount of data from routers. However, those collections were not scheduled, and they were pulling a lot of data, which spiked CPU to 100%, which basically delayed some of the more important routing tasks, such as routing decisions. So as you can imagine, that's quite big of a problem. Or the second one is there is a certain network vendor that markets their solution of being capable to have 500 concurrent SSH sessions, while in practice we realized that basically they can shoot up to 13, right? So there's a lot of stuff in marketing that should be tested. Now, what's the fundamentally problem with all of that? All right, the fundamental problem is time. And why is the time problem here? The time is the problem purely from the perspective of the reactive nature of the troubleshooting. So basically, what happens is that some event happens, and then we are quite slow to respond to that event. So basically, we have a slow response, which is followed by large-scale service degradation, which results pretty much every single time in quite unhappy customers. So all of this is quite big of a problem. So we started asking ourselves whether there's another way. We have an open question here, and if you have an answer for me here, I would love to hear it, because I couldn't find in my research if there's any way to be proactive when it comes to discovering of the potentially service impacting events in the network. So at the moment, there's no published research that I'm aware of. However, what needs to be mentioned is the fact that large-scale companies such as Google, Amazon, Facebook, Microsoft have advantage even on this market, purely because of the fact that they operate quite large networks with large data sets, and at lowest, what they are capable of doing is to have the information about the failure rates of the line cards, which they can basically feed towards the certain statistical models, which can give them information for the procurement. So basically, when their line card for the Cisco ASR or Juniper PTX fails, so that they can replace that line card in no time. So they have the advantage, but that's just a minor example. So now that we realized that we are quite slow to respond to networking events, and when I say slow to respond or slow to detect those events, the worst case scenario is your end user reporting the outage, right? That's a pretty tragic event when it comes to today's standards, right? So we started thinking on how to solve that, and one logical answer came in form of automation. So we realized that there are many companies that don't have 24/7 ops teams and stuff like that, but they are 24/7 companies. So there's a real requirement for that. And then on the other side, we realized that there is a human factor there, and human factor is such we are slow to respond on those events. We know that there's an issue. We take some time to discover that issue, and then basically we eventually find root cause for that problem. So we figured out that we need to automate operations, right? So as part of that journey, we discovered Python and its countless libraries. We discovered Go programming language with its concurrency, and some smart people which realized this even even before we did, created some of the frameworks such as Django, written for in Python, Ansible, Salt, Napalm, and stuff like that, that already try to achieve what we are trying to achieve, and that is to automate operations out of picture so that we can respond faster. So if we cannot predict the event, we can respond faster to the event. So now, uh, what we, once we gain confidence that we are getting good results from the automation, um, and automation did something quite interestingly in large-scale companies, and that is following. Instead of scaling horizontally with the people, they started allowing scaling vertically with software, which is quite important for the large-scale companies because it saves a lot of money, right? So once we gained the confidence that everything is working as expected, we started wondering whether vendors that we are buying the networking equipment from are telling us a full truth about the performance of our networks based on what they are exposing to us, right? So I'm not sure how much of the operational experience you have, but how many times have you heard about line cards reloading as a result of solar flares, right? Uh, what would have happened is that one of the bits in the memory would flip as a result of solar flare, and the line card would reload. Now, the line cards can be 100G line cards, so for example, 24 by 100G, so that's a significant impact to 2.4 tera, right? Or it can be 32 by 10, doesn't really matter. Impact is impact, and you are being told that it's because of the solar flare, right? Is that something that you are going to be happy with? Probably not, right? Or if you're troubleshooting the event where and all of a sudden, like, you realize after opening the case with the vendor that contexts for exactly that problem that you are troubleshooting are not user exposed. That's always frustrating because it adds delay in getting you towards the root cause analysis, right? So that's not desirable. Or if the context exists, you need to be a quite skilled engineer that knows how to attach yourself towards on the line card level to troubleshoot this very low event, and you need to understand a very cryptic nature of the messages that are being reported on that level, right? And in most cases, you need to know in very deep level structure of the ASIC or silicon that's implemented, and those things change. So you need to keep up all the time. Practical example when it comes to those problems, I saw an example where one single packet, which was miscrafted, hit the backplane of the fully redundant N+2 redundant router, crashed the router. It didn't crash the line card. It crashed the line card that had multiple in production line cards. And that wouldn't be a problem per se because the location where that happened was built with N+1 redundancy. However, that very same miscrafted packet hit the other router, so it took complete edge location down. And that didn't happen on one location, it happened on two different continents, and it took two major pops for the company. Once you lose that amount of traffic, that gets to be quite a big problem. And I mentioned earlier there is a rise of the streaming telemetry in the networks these days, and as a result of which we are pushing control plane towards its maximum. And basically the question that we are asking ourselves, can your control plane handle it, right? And control plane has a fundamentally very important thing to do. And for example, if you think about the edge and you're learning around 700,000 prefixes from full global routing table, best path algorithm needs to figure out what are the best prefixes that needs to be installed in that routing table, right? That's much more important than anything else, than collecting the data from the router. So that's quite important. So once we figure all of that, we figure out that automation gave us a product that we call vendor distrust. We figure out that they are not letting us know full operational truth about how our networks operate based on their equipment. And don't be mistaken, we are paying that equipment quite expensively, right? So we actively started thinking about how to resolve this problem. And answer came in the format of the active network monitoring. And active network monitoring, in a nutshell, is basically probing the data plane with the synthetic traffic, as part of which we are simulating production traffic via data plane and then measure experience such as packet loss, latency, or jitter, depending on what type of the applications you are hosting at the top of your network, right? So in the process, we identified some of the challenges of deploying active network monitoring. And those challenges came in the format of large-scale and enterprise networks going towards the class fabrics. What are the class fabrics? Class fabrics are those fabrics that are built with the leaf and spine architecture, as part of which a leaf and spine are fully meshed, right? And the complete idea is to limit the blast radius. How do we do that? We are limiting the blast radius by installing smaller scale devices. Now, instead of having Juniper MX960 with 12 line cards, you are going to install a smaller scale device, which is 1 or 2U, capable of pushing certain amount of traffic. In this class fabric design, as part of which it's going to be one of the points in this multi-device built fabric. That's pretty much what it is. However, if the MX960 or ASR9022 or big vendor chassis such as Arista, Cisco, Juniper had problem with the control plane utilization, those smaller scale devices have even more elevated problem. Because their fib and their rib is smaller and their control plane is weaker, right? So that was one of the problems there. So we started wondering whether those devices are actually smaller scale devices. So I did very small research and figured out what are the vendor provided boxes that are currently being used for this purpose. And leading example are Juniper PTX 1000, which is capable of doing 24 by 100 in, I think, 1U, which is pretty fantastic devices if you think about it. 1U, smaller energy consumption, which is very important thing. It doesn't consume too much space. Heating is not a problem, right? But it still pushes 2.88 terabits of traffic. Right? Then you have Cisco NCS 5000 series, which is 32 by 100, which is capable of pushing 3.2 teras, right? And in the end, you have a 7170 Arista series, which is capable of pushing 6.4 terabits of traffic, right? So the real question is, are those really smaller scale devices? Right? So are we basically doing the pretty much same thing, just with the smaller devices? I guess that the real answer depends on the angle. I guess that it's better to lose up to 6.4 teras of traffic than to lose 160 teras of traffic with a fully loaded ASR 90-2020. So I guess it's a compromise. But let me tell you something, regardless of who you are and what's the company that you work for and what's the network that you operate or engineer, losing 6.4 teras is something that you are going to feel, and that's going to be something that your customers are going to feel. So that's quite big impact, right? So when it comes to conceptual solution behind the active network monitoring, we are speaking about utilizing data plane to measure experience. And basically, that's a fundamental concept here. So we are using either synthetic traffic, as part of which we can use TCP or UDP, and we are simulating user-originated traffic towards the destination. And based on those flows, we are measuring packet loss, latency, jitter, throughput, and whatever you need to measure, right? That's the conceptual design. That's essentially what the synthetic traffic is, or active network monitoring. When it comes to practical applications for this solution, there are certain companies that are providing those solutions, but quite interesting developments are available on, as an open source solution. The most recent one is Matreshka Prober, built by one really cool German dude that put a lot of effort here. As part of which, he creates unidirectional GRE or MPLS tunnels towards the from the source towards the target. And since he's building those tunnels, he knows the complete path, and then he's measuring this experience. So if the problem happens, he knows where the path is. So if he builds 3 tunnels from source to destination, and he receives that there's a problem on one of the paths, he can quickly identify where the problem is. I don't think that Matreshka has the automatic way of figuring out which tunnel produces the packet loss or a certain metric to fail, but it's really cool solution, right? The downside of this solution is, unfortunately, the fact that you need to control those network devices on the path, right? Because you need to install GRE or MPLS path towards the target. The other one is OpenNet NORAD solution, open source by Facebook. It's utilizing UDP traffic and 2 software components called Pinger and Plonger. They are basically using UDP to measure the experience between those 2 solutions. One small downside is that I don't believe it has a granularity to recognize L3 path that's affected, but it can most definitely tell you that there's a problem between A and Z that you are monitoring. So always remember, some monitoring is better than no monitoring. So that's quite an important lesson here. There are some more challenges with active network monitoring. With anything that's pretty much a different approach, there are challenges. And challenges here are on the backbone networks. At the moment, backbone networks are built by either segment routing or label switch networks, segment routing or MPLS. And MPLS, for example, can utilize auto bandwidth, as part of which a network can dynamically react to the networking events on its own. So what's the challenge there? The challenge there is that you have source, you have destination, and you have movable components or paths towards that destination, depending on the network conditions in your network. So how can you basically probe those paths using data plane? It's quite hard because MPLS on those networking events can re-signal those paths. So potential solution for this one is something that we propose here, and the complete idea is to probe underlying IGP paths, right? We know that MPLS depends on the constraint SPF, and for the constraint SPF, you need to run IGP. And IGP in the backbone-related networks is most often used ISIS, right? So instead of monitoring your MPLS paths or LSPs, you are monitoring your IGP paths that those LSP traverse over anyways, right? And based on the constraint SPF, in majority of the cases, best IGP path is going to be the best MPLS path if there are no events such as auto bandwidth, right? So what you do is you create a full mesh of the IGP probing on the backbone. So basically, all of your edge locations that your backbone interconnects, you probe them using the IGP. And if you full mesh those probing, there's quite likelihood that you are going to monitor majority. So the idea here is that some coverage is better than no coverage. Speaking of this, this is well-identified problem that Facebook spoke about. Richard Sheehan gave a talk on the network for isolation, and I know that Google also identified this as a problem, and they spoke about this problem, but I didn't see any proposed solutions, so I believe this is one of the first one out there. So, did we forget about something? And I think we did. We did forget about internet, right? So this publicly shared kind of trust-based infrastructure where everyone can participate depending on certain conditions, right? And our colleague just spoke about some of those challenges when it comes to graphics hijacks and stuff like that, and how to overcome those. But at the moment, vast majority of the internet is trust-based. So what are the problems on the internet? So beyond the transit provider or peering provider that you have, you really don't have too much control, do you? Right? Your provider, depending on who that is. For example, if you are dealing with tier 1 provider, can give you certain BGP communities to manipulate your flows, ingress and egress. However, not every single one does. And even if they do, 3 hops away, you lose that control anyways, right? So what are the potential problems on the internet? It's a packet loss, latency, uh, jitter again, BGP advertisements and withdrawals, and that leads us towards the prefix hijacks and leaks, right? And our colleague from RIPE already spoke about that. So, what are some of the solutions? Some of the solutions here are again commercially available, but also traditional or improved monitoring tool set that I spoke about earlier on can be used. Again, unfortunately, retroactively, right? But for example, you can use MTR. Now, the problem here is really with the time again. Are you quick enough to recognize the event? And does the event last long enough so that you react on that event so that you can catch the event while it lasts, right? That's the problem. Fortunately enough, RIPE had amazing role in this, and they basically provided a RIS, and basically RIS data is feeding BGP Play, which has this amazing data set of BGP events on the internet, as part of which you can target the prefixes, you can target the specific ASNs that you are interested in, and so on. In a very granular way. I don't think out there, when it comes to open source solutions, that they are more granular solution, because I think that you can get granularity up to 2 seconds on the events, which is amazing. So props to RIPE team that did this. So in the end, it's important to speak about the conclusions that we found as part of this journey towards better network monitoring. Learn how to code. This is a big one, right? Inevitably, everything is moving towards the software. We realize that we are not fast enough to respond to events. And this is unfortunately something that doesn't fly very well with the network engineers, but this is our reality. If you don't do this in 5 years' time, depending on the network that you are working on, you're going to be obsolete, right? Because companies are ultimately going to realize that you cannot horizontally scale people, you can vertically scale software. So you're going to be doing remediation frameworks instead of basically jumping on the router when interface goes down. Like that's just a fact. And I saw it in production environment already happening. The other thing is it makes so much more sense to actually deploy and maintain networks by software. For example, you're not dealing with the IP conflicts and stuff like that. That's all taken care of. Very important point here is to utilize research papers. Facebook and Microsoft and Google are quite good at publishing research papers on data center and backbone design. And if you are working at a company that deals with this, utilize those papers. Don't learn those mistakes don't learn on your own mistakes. Learn on their mistakes. And those papers are quite fantastic resource that indicate what can be potential problem with certain design solution, right? Utilize both active and passive network monitoring. Passive network monitoring being SNMP and stuff like that we spoke about. But we, as part of this presentation, hopefully figured out that we cannot trust it, right? So utilize active network monitoring. And this is where the learning how to code ties back in, because in most of the companies you're going to be doing this. Creating solutions that are actively network monitoring your networks. Monitor performance of your internet paths as is life of your packets and patience of your customers depends on it, right? This especially applies for any company or organization that is in content delivery business. You literally depend on this. We live in interconnected world, and you need to know basically performance between source and destination, regardless where that destination is. It can be sometimes within your data centers, which is quite important to monitor, but very often it's somewhere which is not under your direct control, so you need to take care of that as well. And lastly, don't stop there. You need to approach monitoring with this complete holistic approach, as part of which you are monitoring both the network and services in meaningful way. potentially in one place, if anyhow possible. At the moment, we have the trend as part of which SREs, when something goes back with the service that they are taking care of, uh, starts blaming network engineers for the problems, and vice versa. Network engineers goes back and they say like, no, no, it's not us, it's the service that's fundamentally broken. Part of the reason for this is that there is no holistic approach or holistic picture when it comes to network monitoring, and the other reason is that uh, not all of the things are being monitored, especially services are not. So thank you very much, and please let me know if you have any questions.